Hello everyone, I'm Shulin from Shanghai Jiao Tong University, and in this talk, I will briefly introduce our work, ISCA'23, Architecture of Fine-Grained Privilege Control for Instructions and Registers. Let's start with kernel isolation. The theory of isolation is the principle of least privilege. For ideal kernel isolation, we can decompose the kernel into isolated components, and then the compromised components cannot access the other's resources. There have been many isolation systems. However, existing systems focus on memory isolation, but overlook instructions and registers, which we call IC resources. There is almost no isolation of IC resources in existing kernel. The attackers can execute or access any instruction or register with a compromised component. This can cause some security problems. For instance, the MSR150 controls the CPU voltage, and if this register is controlled by the attacker, he can apply the voltage-based attacks. Like the voltage-based attacks mentioned before, there are other attacks which rely on the abuse of IC resources, and we call such attacks IC abuse-based attacks. There are many IC abuse-based attacks, like we list below. The goal of ISCA'23 is to design an architecture to control privileges of IC resources in fine granularity. It should provide fine-grained access control to manage permission of individual instruction and register. It should also provide flexibility to support a large number of isolation domains. It should guarantee security, which means the isolation cannot be bypassed. Besides, it should only introduce limited performance overhead. To support ISCA'23, we introduce some new hardware extensions. We add the privilege check unit, PCU, inside the CPU core. It is connected with the CPU pipeline, and it will check the execution of each instruction. We also add a trusted memory. It stores the metadata of ISCA'23. We have some design challenges here. The first is how to provide fine-grained isolation for ISA, and we use the hybrid grain privilege check to solve this challenge. The second is how to enforce the security of domain switching, and we use the unforgeable domain switching to solve this challenge. The third is how to reduce the performance overhead, and we add the domain privilege cache to reduce the runtime overhead of ISCA'23. If you were interested in our work, see you at Session1C on Monday. Thank you.